This is the next project we want to mill using the Revo C mill. So it's always just a good idea to look at the detail, find out where the important parts, all that good stuff. So you can see we've got, let's just double click on the perspective title bar to expand that view. And you can see there's some bead set stones here at the top, a simple bezel around the princess cut, a little beveled wall, some gallery openings on the side of the shank, some filigree here, and then we've got an opening at the bottom, some hollowed area there. So double click on perspective again to get it back to the 4 viewports, and we're going to enter into the Revo Millworks C Builder. It's also important, again, we emphasize this in the first 2 videos, you need to make sure that you have a ring rail present in the model. Click the Revo C Builder and follow the instructions in the upper left-hand corner. Put your model in the box. Remember to completely encompass the entire model. Make sure it's all highlighted pink and single click the arrow underneath the model box. After you do that, the instructions are going to prompt, I think you're making a ring. If this is correct, select close support setup. Otherwise, click on non-ring model. Basically, it sees that you have a ring rail in there. It knows it's a ring model. So therefore, when you determine the support strategy, it knows where to place those supports based on the ring rail. When deciding what strategy, I always just glance over at the pictures, determine if I can get all my detail with the selected strategy. The first one in the upper corner comes in from the top, in from the back side, and from the front side. This is using the dual fixture. You can see we've got detail on the top that if we approached from the top side and then in from what you see in the through finger viewport and then 180 degrees, we would achieve all that detail. Whereas if we chose the second strategy here, it would only approach from the sides, which would clean up this filigree beautifully, the gallery work beautifully, but the top section where the detail is with all the prong work, all the bead set stones, you would not get with this strategy. The base clamp, again, a perfectly acceptable strategy where it would approach from what you see in the through finger viewport. It would approach from this angle, which is what you see in the side viewport. And then the aqua approach here, the horizontal cutter, would approach the top. So you would achieve all the detail using the base clamp fixture. However, this is going to take a lot more time to mill than this would because of the additional approaches. So for this ring, it's not necessary. We don't have any major detail in the side view. No stones coming down the sides, no pattern on this shank. So we don't really need the base clamp strategy. On the 3-jaw chuck, if we place the ring on the 3-jaw chuck here and the cutter came down from the top and over and back, it would never be able to reach the filigree. So this is not an acceptable strategy. So taking all that into consideration, the time needed to mill it and what is going to approach the strategy or approach the detail, we're going to choose this upper left-hand corner support structure. Now, based on the finger rail again, from the finger rail, from the inside ring rail, the supports are offset 1.5 millimeters from the finger rail. So you can see how nicely they fit in to a ring that's got lots of detail on the side and detail up at the top. Now, when determining what center type we want, remember this one is going to raster path back and forth across. This one's just going to do a quick scoop, or a quick, not scoop, a quick circular path, removing the extra material in the center of the ring. And then when it approaches the mill job, it goes back and forth, down one side, back and forth, and then, oops, just do an undo here, and then up the other side. The third approach here is hollowing, and if we look at the hollowing cutter, if we place the hollowing cutter in here, you can see that it's not really going to do much to help us hollow that out. The disc cutter just isn't ideal for this design. So we're going to have to do some hand detail work underneath here to hollow this out manually. There are ways to hollow it out using the mill, but they're just more advanced techniques that we don't cover in the primary class. Okay, so let's just get rid of these cutters. And we will choose the second strategy here just for time purposes again. Click next to continue to the wax size selection. It recommended that we use a 15 millimeter blank of wax so that we could get all of our detail. We have a 15 millimeter blank of wax, so we'll keep that one selected and click the next button. On this page, the instructions are going to read select the cutting angle options and click next to continue. So we've got different options here, and these little lines or cutters are the approach angle. So again, we really don't want to use just the 2-side approach. We could use the 3-side approach, or we could use the 5-side approach, coming in with some custom angles to clean up any additional wax that could not be reached with the traditional 3 angles. The nice thing about, if you want to choose this option here with the 5 angle approach, it basically does the 3 angles first and then comes back and only touches the parts of the model that could not be reached with the 3 angles. So it analyzes what has not been cut with this approach and comes in and only touches the parts that couldn't be milled with the three angles. So we'll go ahead and choose this, and we'll take a look at it here in the next page. Click next to continue to the cutters and distance between toolpath options. Select cutters and distance between toolpath options. Click make paths to create toolpaths and click next for detailed options. So we're going to go ahead and make our paths. And I'll just pause the video. Okay, toolpaths have been created. Now click Save Paths to save the RVOC file to your drive. I always think it's a good idea to just take a look at your paths and see what's going on. So in order to do that, if you can make heads and tails of this, you know, more power to you. But I prefer to go to the next page, which is the detailed options page, and it allows you to look at each individual section of the path. So click icon to view and edit each part of the job, and click make paths to create tool paths. Clicking back will delete any changes. So we need to go in here and look at each individual path. The first path is an automated path that comes in from both sides, 2 sides, and it does a quick little pass like this, removing the extra wax up on top of the piece. Okay, so it's just a real quick roughing pass to remove all this block of excess wax at the top, allowing us to get in at this detail a lot easier. Also allowing you not to bury the cutter when you come down and approach this detail. The next path down is cutting the center of the finger hole. And the next path down is all 5 passes. Okay, if we want to see all 5 of those passes separated out, if you double click on part 3, it's going to open up the 5 subparts, give us access to those subparts. And when I click on each individual subpart, I can look at the detail. And you can see from the top-down view what's happening here. Actually, that was a good view. It's coming down and it's milling out all of the detail. And you can see it's even going down underneath those stones. So when it sees a stone, it completely ignores those stones. Okay? And then it's also coming down, it's coming down to this depth here. Now, the way I prefer to do these cuts are I like to confine the border where the mill will be cutting. Everything on the top of this ring is the whole reason we wanted to mill with the third side. So all the detail work on this outer face. We don't really care that it touches the top of this shank. And in all reality, you have to think of this as a mold line. It's almost like a mold line. The mill comes down all the way to here and touches, you're going to see evidence of that mold line. Whereas if I confine the mill to only mill up here at the top, then my mold line is right here on the edge. So what we're going to do is we're going to expand this subpart and we're going to do some magic. So to expand the subpart, if you hit the little plus arrow here, it opens up this, it opens up subpart 1, and we have total control over every single detail of this subpart. And what we want to do is we want to change the border that it's using to cut down with. Okay, basically where it's being confined to mill. So if I click on the border window, it gives me an automatic, you can see automatic border is toggled to the on position, and it's set to 0.2 millimeters. That means where it sees geometry, it comes out 0.2 millimeters beyond that geometry and it mills. Perfectly acceptable. However, you might see that little mold line. So to give us the best possible wax off of the mill, I think it's advantageous to add in a border. So we're going to do a manual curve border. Toggle that to the on position. And we need to draw a border that's right next to this outer edge. So what I'm going to do is I'm going to change from the STL view to none to NURBS view. We want our NURBS view, and we want to draw a curve. And there probably already is a curve. There is a curve right here. And we want to tell it to only mill inside this curve. I'm just going to go ahead and delete that curve and show you how I got that curve. If you're in the builder, you know, in the future, when you're doing this every day, you may draw that curve before you come into the builder, like I did. However, if you forget, you can come to the curve menu, and there's an option down here at the bottom, curve from objects. And this is where you're going to find the duplicate edge command, where you can duplicate the edge. If you click duplicate edge, it'll say select edges to duplicate. And we're just going to zoom in and we're going to click all the way around the upper edge of this ring. Don't worry if you misclick and get a curve that you didn't want. It's not touching our curve. It's no big deal. And then it says press enter when done. So I'm going to go ahead and press enter. And while it's still highlighted, I'm going to hold down on the control key and the J key, which is the join command. And if you look up here at the command line, above the command line, you can see I did a control J, which was the join command. It said joining curves, and those 9 curves joined into one closed curve and one open curve. Well, the open curve is this little misclick that I made. The closed curve is going to be our border, and all borders must be closed curves. Otherwise, when the mill says, okay, you want me to mill inside here? Wherever there's an opening in the curve, it gets confused. It's like, well, wait a second. I'm trying to be confined inside this curve, but what do I do here if there was a little opening here? I'm supposed to spill out? Am I supposed to stay in? So it's real important that you make sure that it reads, that it reads one closed curve. Then we can click that one closed curve, make sure it's highlighted pink, and click the arrow underneath the border box. Now it knows it wants us to confine the tool path to the inside of that curve. So let's go ahead and make paths and just check out how that's different from the first one. Okay, it's reprocessed all the tool paths, but we really want to look at that one tool path again, subpart 1. So if you click on any other part and then toggle back to subpart 1, you can see now that this toolpath is being confined to the top section. Okay, so we'll see no mold line along the bottom edge here. And that's really the best way to approach this job. It's a little bit more advanced, but I think you'll really benefit from that little tidbit. Okay, so let's look at the next subpart. That's where it comes in from one side. If we zoom in here, you can see all this filigree is getting milled out. That looks good. And then let's look at the next one. So part 3 comes in from the opposite side. Mills the filigree and the gallery work as well on the opposite side. That looks good as well. Subpart 4. Okay. Now what it does with those angles, it comes in and it analyzes the geometry and it says, what didn't I get with the first 3 subparts? What could I not reach? And you can see it comes in and it cleans up a little bit on the inside of this bezel that it couldn't get from the top down cut. It couldn't get from the side cuts. And then it also comes in to some areas right underneath the stones that it could not reach with the traditional 3 angled approaches. Also, inside the filigree here, it saw some areas that it couldn't reach. Most likely this was, you've got the 10-degree cutter coming in that's got a little bit of an angle on it. You look at the inside of it can't reach all of the wax back here, so it comes back in and gets it with that additional 4th and 5th approach. So the last step here would be to save these paths. So go ahead and hit the save path command. We're going to call this antique and then 10DGR and click the save button.